In question 27 we have data on threshold frequencies and work functions for a selection of metals. In A we're to explain what is meant by threshold frequency. Well, this is the minimum frequency required to eject an electron from the metal surface. In B we have a graph of work function against threshold frequency. In part 1 we're to use Einstein's photoelectric equation to show that work function is the Planck constant times the threshold frequency. Well, Einstein's photoelectric equation is that the Planck constant h times the frequency f, this being the photon energy, is equal to the work function plus the maximum kinetic energy of the ejected electrons. At the threshold frequency, f0, the electrons have no kinetic energy. And this leaves us with h f0 being equal to the work function phi as required. In part 2 we're to plot the data for point C on the graph on the previous page and draw the straight line of best fit. Then in part 3 we're to use the graph to find the experimental value for the Planck constant. Well, if we rearrange the equation as work function phi is equal to hf, this is then in the format of y is equal to mx, because the graph is the work function on the y-axis against the frequency on the x-axis. Therefore, the Planck constant is the gradient. Now for my figures, I got this as being the change in y of 4.2 minus 1.7 over the change in x of 10 minus 4. We need to multiply the work function by 1.6 times 10 to the minus 19 to convert from electron volts into joules, and the frequency is in 10 to the 14 hertz. Very important we don't miss these points off. That gives a figure of 6.7 times 10 to the minus 34, 34, and the units of the Planck constant are joule seconds. In part 4 we're to explain without calculations how we could use figure 27 to find the percentage uncertainty in the Planck constant. Well, we could draw the line of worst fit, and then the gradient of the worst fit line minus the gradient of the best fit line, multiplied by 100 to turn it into a percentage, and divided by the gradient of the best fit line would give us the percentage uncertainty in the Planck constant.